and there are quite a few people in the audience who are very experienced OpenMP programmers or educators. And so perhaps you might think of this. So some of you might just know this stuff already, okay? So that's fine. But maybe you want to think about as we go along is, why do some of these things trip users up? Why don't users know these things? And what can we do to make life better for them? Okay. So a little bit of background about me. So I've been teaching OpenMP for over 15 years now. Okay, so from the very early days of OpenMP to students and to scientists. I had the privilege of being the chair of the OpenMP Language Committee for about 5 years or so. And currently, I also answer questions on the OpenMP forum. So that's a open forum where anybody can just get an account and ask a question about OpenMP, and I kind of take it upon myself to try and, as best I can, to answer those questions. That's very welcome. I really enjoy doing it. It's a lot of fun. I learn stuff. I have to go grubbing around in the dirty corners of the standard sometimes, and I learn stuff. I learn stuff too from doing it. Okay. So this is kind of a collection of some accumulated wisdom. So in particular, it's the kind of thing that you maybe don't find in some of the tutorials. Okay. It's the kind of thing we tend to leave out and not talk about. So I hope you might find it useful if you're a relative newcomer to OpenMP. If you're not, let's have a think about why these things trip users up, or why don't users know this stuff, and what can we do to make that better. Okay, so it really is just a ragbag collection in no particular order. So let's start off at the beginning. Okay, typing in directives. Okay, what happens if I mistype the Sentinel in an OpenMP directive? Okay, well, typically the compiler just swallows it and ignores it. Okay, so in Fortran, if I type $OMP, Fortran compiler says, that's a comment. I'll ignore that for you. Or in C, if I say #pragma OPM or #pragma OpenMP, the compiler says, that's a pragma. I don't know anything about that. I'll just ignore it for you. Okay, so you don't get any error message for doing that. So you need to be really careful. And okay, sometimes you might miss out on a bit of performance by failing to put in a parallel loop directive, but sometimes it can be really serious, right? If I say #pragma OPM atomic, the compiler will happily ignore that, and I have a race condition. Great. Okay, fantastic. Okay, so what can I do about that? Well, one thing you can possibly do is, especially if you know you've got a particular typing habit, okay, I'm one of those people who cannot for the life of me type the word parallel. I don't know why, okay, but it's just one of my it's something I make a typo for all the time. If you know what your common typos are, write yourself a script to just scrape your code for that thing. Okay. Could compilers do a better job for us? Yeah, maybe. It's kind of hard, right? But could you figure out what the common ones are and raise warnings and say, did you really mean that? I don't know. Maybe you could. Sorry, maybe? Okay. So something that's, it's a feature, not well appreciated. How do you write code that works without OpenMP as well? Okay. So there is this macro that's defined if code is compiled with OpenMP switch, so you can use that to do conditional compilation. But I don't think we tend to make much of that. And there's those dummy library routines that you can use if you want to link a dummy version. I don't think many people make much use of that either. Maybe they don't need to. I don't know. Okay. So parallel regions, okay? So one common thing that I see, especially on the forum posts, is, okay, so I wrote my little OpenMP test code, and it slowed down. Okay, and I'm disappointed. What did I do wrong? Well, most likely what users tend to do wrong the first time is that they try to parallelize something that takes a very short amount of time. Okay, so the overhead of executing parallel region is typically in the kind of tens of microseconds range. Now, obviously, that depends on the hardware and the compiler and the number of threads, but it's around there somewhere. Okay, so obviously, the sequential execution time has to be several times more than that to make it worth parallelizing. Okay. So if you don't know, then there's an if clause there you can use to say, okay, you know, if there's enough work here, go parallel, else don't. Okay. Because actually, that's okay. The overhead on one thread is typically really much smaller. Okay. So a lot less than a microsecond typically. Okay. So it's okay to leave parallel regions in there and have them run on one thread. That's okay. I wrote these benchmarks years and years ago. They're still alive. Vendors still use them. Some people find them really interesting too. If you want to know what the overheads are of various OpenMP directives on your particular system, then please use them. Okay. Another common problem that early adopters have is, okay, do I get this thing about parallel loops, right? I have to make sure that my loop iterations are independent. Okay, how do I figure that out? Okay, well, here's a dirty little trick. Okay, take my loop and run it backwards. Okay, and did I get the right answer? If the answer was yes, then most likely the iterations were independent. Okay, it's not infallible, but it's actually quite hard to construct a counterexample for that. Okay, so just quick and dirty thing. Of course, maybe we'd like to have auto-parallelizing technology in all our compilers, but maybe that's just never going to happen. Okay? So I'm quite interested to hear all this discussion about OpenACC and the different philosophy between, should we rely on auto-parallelism or should we not? And OpenMP has always taken this point of view that we do not rely on compilers having auto-parallelizing technology. But there's a lot of smart people out there. There's a lot of smart compilers out there. It seems a shame to me that, okay, so I know that people like Oracle have done the autoscoping type stuff, and there are tools out there. But it seems a shame to me that there isn't a good way to leverage that auto-parallelization technology where it does exist into OpenMP programs. Okay. That seems a shame. Okay, so I understand perfectly why OpenMP takes this point of view. Okay? I think it's good, and I think it's it's an important reason why OpenMP is everywhere. Is that we don't have to, it doesn't need this technology. And it's actually relatively simple to implement. Okay, so you can get a half-decent OpenMP implementation without huge amounts of effort and investment in your compiler. But where those compilers do exist with that cleverness in it, we can't use them. Okay, we can't make use of that technology to make our lives easier as OpenMP programs very easily. So maybe that's something we should think about more. Okay. This is another little one. This is something that we discussed about in the those of you who might remember this. This was long discussions in the language committee at one point. Okay. Is this safe if I do this? Okay. So if I say OMP4 schedule static nowait, okay, and I write some array A, and then sometime later I say OMP4 schedule static, and I read those values. Is that safe? Is that a race-free program? Okay. And the answer is okay, we made this clear in the spec, yes it is. Okay, that is okay. You are guaranteed in this circumstances that the thread that executed a particular iteration in the first of those loops will also execute that same iteration in the second loop. So there is no cross-thread data dependency there. Okay. You hate that, right? So yeah, okay.
But it's in.
It's in, right? So yes, right. That does work. Okay. So.
Not being overly prescriptive.
Okay. Right. So I see we just had a debate in the language committee about what does dynamic schedule mean. I can't believe that, right? Surely we know that now. Okay. Yeah. Okay. Good. Nobody knows this. Okay. Everybody makes a wrong assumption here. The default schedule for loops with no schedule clause specified is implementation defined. Okay. It is not static. Okay. In practice, I think in all implementations I know of, it is static. Right?
Doesn't it say in the spec, though, that it has to be one of the OpenMP schedules?
Yes. It has to be one of them. So it has to be, it has to be a choice from the OpenMP schedule list. But that could be auto.
Oh, now that
right? So, but that could be auto. So in fact, all bets are off, right? So, so an implementation could say the default my default schedule is auto, right? And which allows it to do anything it likes in terms of mapping iterations to threads. Okay. Nevertheless, I think it's huge numbers of OpenMP codes out there do actually rely on this. Okay. They just don't put a schedule clause and they assume it's going to be static. I hope that never comes back and bites people. It does really mean that effectively every implementer has to put static in there. Right? Otherwise, you tend to disappoint customers.
The biggest disappointment right away would be cache effects, in my experience.
Yeah, right. Yeah.
The program may still be valid if you switched it to dynamic or something.
It should be, right, because the
lower performance.
right, it can't break the program. That your choice of mapping shouldn't break the program. But the performance will suffer for sure. Yeah. And I think this is unfortunate because I think it would there are cases where it would be nice that the vendor could make the choice here, right? But in fact they've got their hands tied. They've got themselves into a situation where their hands are tied. They can't do anything. But okay, right. The other thing that people also don't realize necessarily is that schedule static is not a complete specification. It doesn't tell you how you should deal with the remainder if the number of iterations does not divide exactly by the number of threads.
It doesn't tell you exactly, but I thought it said only one of the blocks is smaller. Does it?
No, it doesn't.
It doesn't.
It doesn't say that. Yeah. Yeah. Weird one. Okay. So one of the nuisance things you have to do sometimes is if you decide you want to use static with a chunk size or dynamic with a chunk size, somehow you've got to figure out what the right chunk size is. Okay. Now, in my experience, tuning the chunk size is tricky, and the reason it's awkward is that the optimal chunk size can depend quite strongly on the number of threads. And you don't know how many threads you're going to use. Right? So I've got to ship some code. I've got to fix the chunk size somehow. But I don't know how many threads the user's going to use. Okay? So actually, it's actually often a lot more robust. The thing you actually tune is not the chunk size, but you tune the number of chunks per thread. Okay? And then you derive the chunk size from that, because chunk size expression doesn't have to be a compile time constant, it can be a variable. So tuning the number of chunks that each thread gets tends to be a lot more robust against changing the number of threads than tuning the chunk size directly. So OpenMP, bless it, has these two ways of saying inside a parallel region, I'd like one thread to execute this piece of code. Okay. So you've got single and you've got master. Okay, so they do something similar but different. So which one should you use? Okay. Well, in principle, master should have lower overheads. Okay, so master simply translates to if my thread ID equals 0, else. Okay? No synchronization required. Okay? It's a very, very lightweight implementation. Single requires some synchronization because single says the first thread that gets here executes and all the others have to go and skip and sit in the barrier at the end. Okay? So the first thread that gets there has to set some flag which says, I got here first, which the other threads then look at to say, oh, some other thread got there first. Get over it. Okay. Yes, Rude?
Well, I always wonder, I don't like the master. No direct, no way. I can always do single no way.
You can do single no wait, yeah.
There's another thing that I don't understand. The master tends to be quite busy with other tasks as well. Why give it more? I don't use it that's available anyhow.
So what's the master doing, right?
Well, look at the dynamic schedule, allocate work. So usually the master thread is assigned to do.
Is it? Okay, I thought it was kind of distributed there, but maybe not. Maybe I'm wrong. Yeah. Is handing off, is already doing stuff in the background. Okay, that's interesting. I hadn't really thought about that. So this is a weird design decision. So it's taken right at the very beginning of OpenMP to have this asymmetry between master and single. Okay? Single has a barrier by default, which you can get rid of with no wait. Master has no barrier, but you can add an explicit barrier. Yeah? So why? I've never understood that. That was just weird. No, but why what?
I was there and I don't remember. I mean, I know that a lot of us said, why do you even need master? I go, if ID equals 0. And master was put in because at that time there were a lot of people who were offended by any code that asked for master.
Yeah,
So
I think so.
That's why there was the push to put master, but why the asymmetry with single? I don't remember because we didn't keep notes. It's lines.
Master is a good way to just print something.
Sure.
Oh yeah, it has a lot of handy stuff.
Yeah, I mean,
But why
yeah.
doesn't it have a barrier?
Why doesn't it have a barrier?
Why
Why
is
is
it not a work share construct?
Because if you just print something, you don't have to synchronize all the threads necessarily.
so you can do master no wait. That's what's the problem. Right? That's right. Yeah. It's a bit weird. Okay. Something that nobody teaches is the Fortran 90 array syntax and work share. Okay. So this, just to make you, if you don't know, this exists. Right? So the problem is if you have Fortran 90 array syntax, you don't have an explicit loop to parallelize. And if you don't use workshare, then you have to refactor your code to expose explicit loops and so on.
Have you ever encountered an application that uses it?
No, but yeah, it's a shame, I think.
Has there been any talk of deprecating it?
No, we don't deprecate. We've never deprecated, we've never really talked about deprecation. Yeah. So don't bother. Just rewrite your rewrite all your array code as loops anyway. Okay. Oh, such a common source of bugs. Okay, uninitialized private variables. Can we not warn people about this? Right. Most of them are lexically in the construct, because that's where you use private variables. You know, if I didn't assign, you know, if I see a use before, declare something private, see a use before an assignment, can we not catch that in compilers? First private is useful for tasks, yes, absolutely, okay. For parallel regions and so on, of course you can use first private, but it's more likely just to be an error, okay? So the use cases for first private are surprisingly rare, okay? Especially with loops, right? So it's usually something you're going to, you know, if it's going to be private to a loop iteration, you're going to assign it and then use it. So why do you want some initial value in there? So every time I just tell people, if you think you want to use first private, then you probably didn't. Okay, you either have a mistake, you either have an error, or it's a read-only thing, and you should just make it shared anyway, because otherwise you're just making pointless copies. That would be nice. Yeah. Okay. So you can at least catch those things. Okay. Right. Default none. Okay. I believe this was the worst single design decision in OpenMP.
What? Default none?
No. Not making default none the default behavior.
Oh, okay.
Okay. Right. Default behavior for parallel regions and work sharing constructs is default shared. Okay. This is madness. Okay. I don't know why again, I wasn't there at the beginning. I have no idea why this was done, why this was thought to be a good idea. No. Yes, you have to type in lots of stuff, okay? Good, right? Why the problem, okay? It's just dangerous, right? It's just dangerous. It just results in, I see so many race condition bugs in people's OpenMP programs because of this, right? All the time, okay? So yes, if you support autoscoping, great, okay? You get around all this stuff. You just do it for them, okay? So you have tools that do it for you, that would be fantastic, okay? So what I recommend to people that I teach is just use it, okay? Yes, it's painful, but it's going to save you. You might think you're doing a lot of extra typing, but in the long run, you're going to catch a lot of bugs like this, and it will stop you shipping buggy code. Okay, just use default none, and I say, really, really mean it. Okay. Yes. Okay. So that would be nice, but again, it was not unaccepted. Okay. My observation is that the reason you think this is, you think, okay, surely you can look at 10 lines of code and list all the variables in there. Okay, right? Go on, do it. Why is that shared by default? Because it's just a regular old variable, right? Oh. Not for C. Well, the problem is that the for construct in C is really a general thing, okay? It's just a general while loop. So you can write anything you like in there. Why isn't the private in the first one? Okay, because that's, right? It would be crazy not to be, right?
Yeah,
there's no conceivable use case of that. Right, but there, so what the trouble is, C does not distinguish that, C language does not distinguish J as anything special. It's, there's no concept of a loop iterator in C. Okay? So that kind of thing is a really common bug. Okay, because people look at it and think, oh, they just miss it out. Right? Okay, so a lot more, if you scope your variables correctly, okay, or in a more modern way, so if you write for int I and for int j, then you don't run into this kind of thing. But nevertheless, my experience is that this kind of relying on the defaults and relying on you looking at your program and convincing yourself that you actually did think about every single variable is highly dangerous. Okay? So programmers are really bad at this. And this kind of thing is especially nasty with sort of loop temporary things like this. If you have enough compiler optimization, you'll never see the bug. Okay? Compiler will put J in, will essentially just use a register and decrement it. Okay? So J will never actually be stored in memory, so no race ever actually happens. Until 3 years later, somebody comes along and recompiles your code with -0 and it explodes in their face. So, yeah, okay, enough preaching about that. What could we do? Compiler switch that made default none the default? Would be nice. Or an environment variable or something that that you do to just turn that behavior on. Yeah, but the environment variable is kind of compile time thing. It's a compile time thing, yeah. So a compiler switch, right? Why not have a compiler switch to make doing this easy and thing. Yeah. Okay. This one actually came up in the forum last week. I've seen it several times as well. Is access to private variables from outside of the construct itself. Okay. So suppose I have a parallel region and I make foo a private variable. Okay. And then inside that and foo is a file scope thing, or it's in Fortran it's a module variable or something like that. Okay. And I call some function. And some function, okay, sort of says, okay, I want to use foo. So, okay, what happens? Okay. This is weird. Okay. One of two things. The spec says one of two things can happen. Right. This foo either refers to the original global storage, or it refers to that private copy. But I'm not going to tell you which. Okay. So it's completely unusable, right? You can't do that, right? So because if you don't know which is going to happen, which things it's going to refer to with different compilers, then.
I thought the spec said this is undefined.
No, it says it's just unspecified which one you get, okay. Right? It tells you you're going to get one or the other, but not which one. Which is what on earth uses that?
Well. The use line is don't do it.
Maybe. Yeah, maybe it should just be undefined. You think it's undefined?
It should be undefined if it's not.
We could add, say on Tuesday, it would be the private version and the rest of it.
Well, yeah.
That's important.
Yeah, I mean, this is interesting because I thought the spec said it was undefined.
Maybe I should go back and check. Okay, I'm not 100% confident there.
But undefined is still a problem because you're going to get the wrong answer.
Right, but at least it says it's an error, right?
But at least in the specs it's clear that it's an answer.
Yeah. So you just can't do that, right? It's just wrong. I don't think the trouble is there's no good way for compilers to catch that kind of thing, right? because that could be compiled completely separately. So how would the compiler ever know?
That's why we don't say it's error.
Though, I mean, most of the problems occur because of inlining, right? So in that case, if the compiler does inline, then it probably might be able to pick that up. Said I inline something, okay, so I see that foo there, and I'm going to make it the same as foo there, and therefore, oh, but foo was private here. Whoops. But can it tell that you didn't pass a pointer to it some other way legitimately? No, maybe not. Okay. Maybe you just can't do it. After the directives, yeah, I think that's the trouble here. Okay. Right. Okay. What do I do with this situation? Okay, this is also to do with data scoping. Okay, so unfortunately, there's a lot of Fortran out there in the world that looks like this. Okay. Do I equals 1 to n, and then you get literally several pages of inline code, okay, which reference hundreds of variables. So I have to try and determine the correct scope for all that stuff. Okay. So if I'm lucky, I have an auto-scoping tool. Okay. If I don't, then I'm a bit stuck. Okay. Because then the chances of me getting it right are hard. Okay. But so what I generally recommend people to do in this situation is say, so go away and refactor your sequential code until it looks like this. Okay. All the loop temporary variables, declare them locally inside that subroutine. Okay. And everything else, pass it through the argument list. And that's much easier, okay? That's a sequential refactoring, which you can test sensibly. And then you can parallelize that, and you've got rid of all your private variables. You've made the decision, okay? Everything that should be private is locally declared and therefore implicitly private inside that subroutine. Everything that you needed to pass in probably needed to be shared, but at least you've probably reduced the number of variables you have to make decisions about by a lot. Okay. So if you don't tend to see this so much in C programs, just because of the background of where people come from. But you can declare them in the scope of the loop body and make them private implicitly without having to list them explicitly. And again, that's it. Is to be able to do this, yeah, it probably is. It's probably part of the recent Fortran standard that nobody will implement for another X years, and OpenMP will not support for another Y years. Okay. So yes, but yeah. Is that 2008? Is it, or the more recent, or these? Yeah. It's a nasty one I've seen bite a few people. Okay, so I have a parallel region, and then I have a for loop with a reduction on it. So I need to initialize the value of sum somewhere. Why is that broken? It's broken because, okay, all threads do that initialization. So it's wrong, right? It's a race condition. Okay. It looks like one of these really harmless race conditions, but in fact, those things are not just racing with other threads executing that. They're also racing with the implied assignment to sum at the end of the parallel region. Okay? So it's possible that a thread gets in here and gets right down to here, adds its local copy of sum into the original storage, and then another thread arrives and sets it to 0.
But that would only happen if one thread finishes all of its iterations
Sure it would, yeah, yeah, yeah.
Pretty rare to get that.
Sure. But then, it's like any race, it's like a lot of race conditions, they're rare events. Which is a problem, yeah. It won't happen very often. It's one of those that, you run your code 999 times and nothing breaks, and then the 1000th time it goes poof in your face. Okay?
So
That's a nasty one.
initialization in a single.
You really need to put the initialization in a single and and make sure there's a barrier there. Yeah. Or master plus barrier, if you wish. Right.
Master plus barrier. But you're right, that's a race.
It's a,
Compiler could just exit when it gets that state.
yeah, sure, it's a race, right? Yes. Yeah. But it looks like it ought to be a harmless race, but it isn't. Okay. You really can get the wrong answer from that. Okay. As opposed to it just being, well, okay, every thread assigned the same thing to some variable. Mumble, mumble.
I thought that the resolution was done when all the threads finish at the execution of the loop.
No, there's nothing to specify that. Okay. A thread can add its local contribution into the original storage before other threads arrive at the barrier.
So if we use the nowait clause and we add an extra barrier,
If you use a nowait clause, then you just push the problem later on.
So if I remember correctly, the definition of reduction in the context of nowait, you were not guaranteed of seeing the properly produced
So,
result of
yeah.
reduction until the following barrier.
That's correct. If I have a reduction with a nowait, then I don't get the result. The reduction result is not available until the subsequent barrier.
yeah, for this reason I'm adding an extra barrier to wait for the results. But the thing is that we are doing partial reductions before having the while on the barrier.
Yeah. Yeah, that's legal. Okay, so some implementations may, because they fold, some implementations may fold the reduction into the barrier in such a way that this doesn't happen, but you cannot rely on that. Okay. Oh, this is a good one. Yeah. So you occasionally see users, and their first experience of OpenMP is, okay, I've got my sequential code. I know I'd like to use OpenMP. The first thing I need to do is figure out what the compiler flag is to use OpenMP. Okay? And I think, oh, okay, I'll just add that and I'll just recompile my sequential program. Boom. It crashes. Okay? Well, there's a couple of reasons for that, okay? Sometimes it's a code bug, okay? It's a missing save or static, okay, depending on your language. Okay? Because what compiling with OpenMP flag does to a sequential program is force all local variables to be stack allocated. Yes, okay? They must be private to a thread, so the only sensible place to put them is on the stack.
So even if I don't have a parallel region,
And if I don't have a parallel region, variables which are local to a subroutine have to get stack allocated. Okay? Because I don't know where, I could, as far as the compiler is concerned, is because the OpenMP flag is there, this routine could be called from a parallel region. So I better treat the local variables in such a way that they're going to be private to a thread, because that's the rule.
doesn't the compiler always put the local variables in the stack?
No, especially not if they're arrays of any reasonable size.
Yeah, of course.
Okay, so if they're scalars, then yes, probably. Okay, if it sees it's in, it knows it's a big array, then it has the choice, right? It can heap allocate them, and a lot of compilers do. So that can happen. Okay. The other reason why your code might have blown up in this circumstance is because, okay, you did have some big arrays and you just blew your stack away. Okay? It increases the stack requirements, and suddenly it goes over the stack space limit, and you die. I cannot get my head around the fact that modern languages are so sophisticated, etc., 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 but still Stack Overflow results in segfaults. Right? Why? Can't you catch that? Can't language runtimes do it? Do something sensible? Huh? You should tell they can't. Unbelievable, right? It seems amazing to me. Okay. So if it is the case that you did really need save or static, then those things are shared by default, and you may need to make them thread private. The problem comes with a lot of the use of those things is for first time through code, and you need to think about that really quite carefully as to how you refactor that. Okay, that's a bit of an awkward thing to deal with for applications. I have codes in it. If this is the first time I got called, then do something, and then set this flag so that it never happens again. Probably bad programming practice, really. Okay. But if you then want that thing to be called in parallel, then what does that mean? Okay, and then we have a bunch of threads who are all going to try and execute it at the same time. What do you want to happen? Sorry, little? That's fine. Yeah, that's fine. Yeah. Okay, yeah, so it's running if you run out of stack space, okay. But you've got to control stack space in two ways. Okay, you've got to deal with the master thread stack in whatever way you would normally deal with it for a sequential program. So you use a ulimit or you set the right setter compiler flag or whatever. Okay, because OMP stack size only affects all the other threads. Okay, so you've got to do this double thing. Another gotcha is critical and atomic don't mutually exclude. Okay, so if I do this, if I try and protect the same variable with a critical and atomic, then one thread can be doing this and another thread can be doing that. That's bad. Nobody seems to know about nobody seems to. I try to teach it, but people don't seem to ever know about OMP get max threads. Okay, and the use. Why do you want to use OMP get max threads? That's because you want to allocate some storage based on the number of threads ahead of the time for the next parallel to use in the next parallel region. Okay, and that's a nice way to do it. Okay, again, so this is an unfortunate decision, early stage of OpenMP. So we didn't have the concept of ICVs, so the names of the runtime, those runtime libraries are not getters and setters properly. Okay, so OMP get num threads is not a getter for the ICV.
Right.
Okay, OMP get max threads is the getter. Okay, but yeah, just be aware always that implementations can always give you less threads than what you thought, and you should always check if you care. Okay. Using tasks. Tasks are lovely. Data attribute scoping for tasks is horrible, difficult. So as usual, use default none. Right? Don't rely on the defaults. Think about because you really do need to think about things carefully with tasks. Okay. Don't use tasks for things to do loops, to do normal loops, because you've just got bigger overheads. And don't expect runtime to do miracles. Okay. So usually you need to take some control over the number and the granularity of tasks that you're going to generate. Generating billions and billions of tiny tasks is never going to work. Okay. For performance. Okay, so if I really want my OpenMP program to run and be very aggressive and not be nice to any other user, then I need to set, there's 3 things I need to set, okay? The OMP wait policy is active to get my idle threads to spin instead of to sleep. So OMP dynamic equals false, so don't let the runtime give me, or at least give a strong hint to the runtime, not to give me fewer threads than what I asked for.
But that's not what that means. All that means is that it will vary the default number of threads.
Right. It can still give you less.
It'll still give you fewer.
Right, but it's much less likely.
I'll
Okay.
give you
Yeah, it's much less likely.
that. Correct.
No, it's yes. Okay, that is true. Just don't let it. Yes. Yeah. Okay. No, you're right. Okay, that's too strong a statement. It's a strong hint saying, please give me the number of threads I asked for, and bind them. Okay. Don't move them around. Okay. Unfortunately, these are often not the defaults because vendors seem to think that that all programs should be, all OpenMP programs are run in shared environments and everybody should be nice to everybody. Okay. So even on supercomputers where you are guaranteed to get a whole node to yourself anyway, then you still need to set those in some cases. No, they're all implementation defined defaults. Yeah. So implementation can do what it can set those how it likes, and usually most implementations go on the sort of nice, friendly, cautious side with their defaults. Okay, debuggers. Yeah, debuggers are pretty exist. They're great, but they don't track down race conditions for you. You need to use tools like these. Intel Inspector or Thread Analyzer to get race conditions. Okay. It's great. Okay, and last but not least, you'll be glad to know. Okay, if you're using timers, make sure the time that you use actually does measure wall clock time. Okay, if that's what you wanted. So do use OMP get W time. It's an extremely convenient timer. It's defined precisely the right way. It returns exactly what you want. It returns you a double precision value in seconds. You don't have to convert it to anything. You can just print it out directly. You can subtract it. You don't have to mess with it. Okay. Don't, for example, use clock. Okay. So the C clock function. Okay. That measures CPU time accumulated across all threads. Okay. So if you use that, then no wonder you don't see any speed up, right? I've seen any number of people do this. Okay, it's really common. It even happened to one of my colleagues, who will remain nameless, because I don't want to embarrass him. Okay, but he came to me and said, "It's really weird. My OpenMP, I'm getting no speed up in my OpenMP." And I said, eventually I got to the bottom of it. What are you timing it with? Oh, clock. Oh, that's all right, isn't it? No. If you saw no speed up, then that means, if you saw no increase in CPU time, you were getting perfect speed up. Relax, don't worry about it. Okay, I'm done. Thank you.
Question? Comments? Feedback? Well, probably the clock call is the one that makes people claim that OpenMP is inefficient. Yeah. Right.
The first one, the common fragment
Yeah.
spelling,
Yeah.
is a problem because compilers are trained to accept anything.
Yeah.
And having an error policy somehow would be a useful thing, and I admit, but I don't know how to solve that problem.
No, I don't know how to solve it either. Yeah.
Well, at least our compiler spits out a diagnostic saying unknown prop.
The problem is you can't spit out it because that you would just drown people in diagnostics if you just
That's what our compiler does.
Unless you really tell it not to, right?
Exactly. It also tells you when you turn off OpenMP. For each problem, it tells you.
You didn't mean that.
That's pretty annoying over time.
one that I've seen, which at the time I thought because I just started people just saying common fragment working parallel, and then it starts writing code, and then not realizing all that's doing is just spinning up threads. That's pretty common.
Yeah.
If you're using for none, you can
compiler should not raise a. Yeah. The compiler shouldn't do that, I guess. Is that right? Does that make sense? No, compiler has to.
You're going to do default none, don't you have, doesn't the compiler have to take you at face value and report any variable it sees in there, even if it's a global or macro as a case? Standard C library values.
Right. This is the reason that you can't do default privates in C, right?
Yes.
It's because of these built-ins. Yeah.
So now you know why we can't have default none in default.
So why default is not correct?
Oh, well,
Because-
default private in C doesn't work because, and I want to, when I say this, I always say, I am parroting words my favorite compiler told me. Is that in the C standard library, there are things, like standard error, that look like a variable and might be a variable, but they could also be a macro. And there's no portable way to say one way or the other. Therefore, default private could not be implemented and supported in C. And that's why it's not in there to this day.
But-
It really irritated me because it meant you had this asymmetry between Fortran and C.
I've never understood it because surely the compiler knows about those things.
Compiler people are widely.
Yeah, they
Just
probably
have
are.
to trust
Yeah,
them.
you have to trust them. Okay. So, I mean, you can still use default none to debug your code. Okay? You can still use it to catch things and then, right? Yeah, yeah. So, you can still use. Yeah, yeah. So, but you can still use default none to get the compiler to tell you all the things you didn't list, right? And then maybe you can't leave it in the code. And maybe you don't want to leave it in the final version of the code because you end up with these long lists of variables. Okay? So if you figure out that actually I've got this huge long list of variables, but once you've convinced yourself you've thought about it correctly, I don't mind if you end up writing default shared in the final version. Okay? But not not until you've convinced yourself you've thought about everything. Yeah. No, useful. Yeah.
Probably one quick question. Going once, going twice. Well, thank you, Mike.